Okay, we're going to be looking at finding the area of a triangle. The triangle formula uses sine as part of it instead of using 1/2 base times height. But let's take a look at how we actually find the area when we're not given the height. So if we want to find the area of a triangle, we know that the area of a triangle has the equation of 1/2 base times height. Now, often you don't know what the height is, so we need to find a way to work around this. But let's say we knew what angle C was. And if I put in the height, then, and if I knew what angle C was, then I could possibly solve for what the height is right here. So, given angle C, we have sine of C is equal to opposite, which is H, over hypotenuse, which is A. Solving for H, I get H is equal to A sine C. So I'm just going to take A sine C and replace the H up here. So now I've got 1/2 BA sine of C. So just to make it alphabetical, we'll have the formula as 1/2 AB sine C. Okay, so this is the formula. All you need to get in order to use this is be able to get the sides that correspond with A and B and an angle. So what do we actually need? Well, if we have base and height, we can find the area of a triangle. Or if we have side angle side in a triangle, we can find the area. So that's what we're going to be looking for. We're going to be looking for side angle side. So here's a basic example. We want to find the area of the triangle. So if you notice, we are given a side, the angle in between, and another side. So I'm just going to plug in. So it's 1/2, doesn't matter the order you put your sides in, 22 times 18 times the sine of the angle between them, which is 33. Punch in your calculator. We have 107.84, and since we had feet times feet, our units are going to be feet squared. Okay, now that's going to probably be the easiest type of an example. Usually you're going to have to do more work than that. So in a real life example, what's likely to happen is you're going to be given 3 sides of a triangle and you need to find out what the area is. This is what people are going to use in a real life situation. So if they want to figure out the area, they can easily measure the sides, but it's really hard to measure angles. So we're going to use one of the formulas we know. We know we're going to have to use the area formula if we want to find the area of the triangle. Then we have the law of sines and we have law of cosines. Well, we're given side, side, side. The formula we're going to be using is going to be the law of cosines. So I need to find an angle. So I'm just going to put an X in here. And we're going to use the angle between it, so it doesn't matter which X I chose. So I've got 5.3 squared is equal to, and again, remember when we use law of cosines, these 3 are together, so I'm going to be on one side of the equation. This one's by itself. So I've got 5.3 squared is equal to 4.8 squared plus 7.3 squared minus 2 times 4.8 times 7.3 times the cosine of the angle between them. So notice that 5.3 is by itself, and these 3 pieces are kept together. Okay, so remember when we solve this one, first do the 5.3 squared, that's 28.09. We're going to add those 2 pieces together, gives us 76.33. Add these 2 pieces together, we get 70.08. We're going to subtract 76.33 from both sides, divide by negative 70.08. We get cosine of x is going to be 0.59917. Inverse cosine means the angle there is 53.19 degrees. So now we have a side angle side. Calculating it out, we just have to do 1/2 the two sides multiplied against each other times the angle between them. Since we have centimeters, our final answer is going to be in centimeters squared. Okay, so that's probably a pretty typical problem you're going to come across. Now that might be part A of a problem. Part B might be actually trying to find a volume or something. So let's take a look at an application problem. So here's where you would use this in a real life application. So somebody's got a triangular region they're going to go over and try to make a pad for. So they have a triangle concrete pad, and we're given lengths of 22 feet, 25 feet, and 30 feet. And the pad is going to be poured, it's going to be 3 inches thick. Now, even though it says, well, how often does somebody do a triangular pad? You may not do it, but you can break things up if they're straight sides into triangles, and then you can calculate your area. So this may even be a part of the problem. So we're going to look at this one right here, and if I need to go over and figure out what the volume is, which I'm going to need. So they're going to be buying bags of cement. And you mix the cement, and there'll be 50-pound bags, which you don't really need for the problem. And each one will cover 1/2 of a cubic foot. So we need to figure out how many cubic feet this pad will be so we know how many bags to buy. So we have the form, and that's shown right here. So in order to find out what this area is, any kind of time you have a shape that's the same moving upward, you have a common base and it's the same just going with the height. The area is the base area times my height. I need to figure out first what is the base area. So we have a triangle with sides of 22, 25, and 30. I need to find an angle. And you could choose any angle you want to find, but I'm just going to choose the one that's right here between the 22 and the 25. So again, I'm going to need to use the law of cosines to figure out what this angle is. So again, there's my side angle side, and that's what I need to get my area. So using the law of cosines, 30 is by itself. 22 squared plus 25 squared minus 2 times 22 times 25. Cosine of the angle between them. Simplifying it, we get 900 is equal to 22 squared plus 25 squared is 1109. 2 times 22 times 25 is 1100. Solving this, subtract 1109, divide by 1100, we get 0.19 equals cosine of x. Do inverse cosine, and we find that angle is just right around 79 degrees. Now, it would probably be fine just using 79 degrees in a real-life application. So now to find the area, we do 1/2 22 times 25 times the sine of the angle between them, and the area of this triangle almost comes out perfectly to 270 square feet. Now, that just gives me my base area. I've got to find out what the volume is. Now, my height is 3 inches. I need to get my answer in cubic feet. So 3 inches, and there's 12 inches in a foot. I need to change this into feet. So I'm going to do a quick little dimensional analysis. Inches will cancel. I get 3/12. This is going to equal 1/4. So I have 1/4 of a foot. So if I take 270 feet squared times 0.25 feet, I'm going to end up with 67.5 cubic feet. That's my volume. Now each bag of cement covers 1/2 of a cubic foot. So if I divide that by 0.5, you're going to need to buy 135 bags of cement. That's if you want to try to build it yourself. Okay, so that's a good typical application problem that you might see on a more on a bigger test. Okay, another application. Let's say you have the area of a triangle and you're going to try to find out what the missing side is. So we have to do a little bit of problem solving on this one. We have sides in the triangle of 20 inches and 15 inches. and I want to know what that missing side is. But I don't have any angles. So, but I do have the area. Well, again, the area formula uses side angle side. So I'm going to take these two sides together, and I can use that to find the angle between, which I'm going to call theta. So the area of the triangle is 120 is equal to 1/2 times 20 times 15 times the sine of the angle. So I have 120 equals 150 sine theta. Solving, I got 0.8 equals sine of theta. Do inverse sine, get 53.13 degrees. So now I know this angle is 53.13. Okay, now to find the missing side, I can use law of cosines. We have x squared is equal to 20 squared plus 15 squared minus 2 times 20 times 15 cosine of 53.13. You can punch all that straight in your calculator. You get 265. Take the square root. And the missing side is 16.28 inches.